In this tutorial, we're going to convert a Java Spring Boot project into a Kotlin Spring Boot project, auto-magically. And we're going to learn some Kotlin along the way. For those that don't know, Kotlin is a programming language and it can run on the JVM much like Java, but it can do a whole bunch of things that Java cannot. So we need a Spring Boot project that's been written in Java. So we're going to use the one that we created as a part of the Spring Boot for Beginners course, the REST API for dealing with books and their authors. Now you don't need to have taken that course in order to use the code for our tutorial today, but if you did want to check the course out, there's a link in the description below. It's up here for free on YouTube. To make things easier, I've taken that code and I've put it into its own GitHub repository. So if we take a look over here, we've got this URL. And in this URL, we've got the 0 Java books. We're going to be adding more to this as we go on. But inside of here is the Spring Boot Java project that we're going to convert into a Kotlin project. So what we're going to do is grab the URL up here. And we're going to use this to clone this repository down onto our local machine. Depending on which operating system you're on and which tool you choose to use, this might be a little bit different, but I'm just going to use a straightforward terminal as I'm on Mac here, and I'm going to go git clone and then the URL, and that's going to clone it down to my local machine. Great, easy as that. And now we're going to open this up in IntelliJ. Using IntelliJ for this tutorial is very important because the same company that's behind IntelliJ, JetBrains, are the same masterminds that are behind the Kotlin programming language. So, as you can imagine, IntelliJ has unparalleled support for Kotlin. Now, there's two versions of IntelliJ. There is the free version and the paid-for version. We're only going to need the free version for today. If you have the paid-for version, awesome, you can use that too. So with the project open in IntelliJ, we're just going to make sure that it works before we try and convert it over to Kotlin. So we'll open up a terminal down here, and we're going to use the Maven wrapper that's been bundled along with the project. And we're going to go Maven clean install. So there we go, build success, looking good. And you may have noticed that a whole bunch of tests run as a part of that build. And we're going to be using those tests in a moment when we convert it over to Kotlin to make sure our project works absolutely fine once it's converted. But before we start, we're going to need to know a little bit about this project. And I think a minute is going to be enough to break this down. So this project is a CRUD REST API, and that stands for create, read, update, and delete, which are operations that we can apply to certain resources. In this case, the resources are authors and the books that they write. An author can write many books, but in this system, a book can only have one author. This project is split into 3 different layers, with the upper layers relying on the ones below it. At the lowest level, we have the persistence layer, which is concerned with reading and writing from our persistence, which in this case is a PostgreSQL database. In the middle layer, we have our business logic or service layer, and that's where all of our rules and our logic is implemented. And at the upper layer, we have our presentation layer, where all of our information, all of our data is exposed to our users, in this case via a REST API. A REST API with create, read, update, and delete operations for both books and authors. This project is using Spring Boot version 3.2.2 and is currently using JDK 17, but should work exactly the same on JDK 21. And it's currently written in Java. We're going to convert it to Kotlin. So vanilla Java projects usually have a whole bunch of boilerplate code. And it's called boilerplate code because it can be automatically generated. There's nothing novel about it. I don't really know where the boiler comes in, but besides the point. So all of this code can be generated. So in the Java version of this project, this one we're looking at right now, we're using Project Lombok in order to generate a lot of this boilerplate code for us. However, Lombok doesn't play nice with Kotlin. So we need to remove Lombok, de-Lombok the project before we can convert it into Kotlin. So we're going to go to the classes that have Lombok in them, which in this case are the domain objects over here. And we're going to de-Lombok the project. So we can right click on the class here. We're going to go to refactor and we're going to go down to de-Lombok and all Lombok annotations. And we'll notice all the Lombok annotations at the top here will be replaced with vanilla Java. So we can see the classes look a little bit different. This green line obviously highlighting what's changed. And we can see here we've got the constructor, we've got a builder, all of the Lombok annotations have been removed and replaced with vanilla Java. Now, this approach seems to have worked absolutely fine for every class that I've tried it on, so I'm going to quickly apply it to all of the classes that have Lombok in right now, and I'll commit this to the repository as well, so you don't have to do the same thing, and you can just skip straight to the Kotlin. And that's all done. Now we're going to add Kotlin to our project, and this is how you do it. We'll go up to the toolbar up here, we're going to select Tools, we're going to go Kotlin, and we're going to select Configure Kotlin in Project. We'll select all modules and we'll go with the Kotlin compiler runtime of 1922. That seems to be the latest one here. Big version 2 is on the horizon, but we'll use this one for the minute and we're going to click on OK. Okay, so that looks like it's worked, but what's changed? Well, we can see the POM file's been brought up here. So let's take a look through the POM file. We mentioned earlier these little green bars on the left-hand side highlight differences, and we can see that the Kotlin version property has been added here. Version 1922, the one we selected from the modal. If we scroll down a little bit more, we should see some more changes. Okay, so we have a dependency here of the Kotlin standard library, and then our Kotlin version property used. We also have a Kotlin test dependency, looking good. And if we scroll down here, we have a plugin, which is the Kotlin Maven plugin, which is then used for using Kotlin with Maven. It's got a compile configuration in there, looking good. So it looks to me like Kotlin is configured for our project. Now, I happen to know this isn't everything that we need, but it's a great start. So we'll add a little bit more to this as we go on. But now for a really big gotcha. When you do this, you absolutely need to remember to refresh your Maven changes. Otherwise, IntelliJ can get a little bit confused and say you haven't got any Kotlin in your project and recommend that you add Kotlin to your project and add multiple versions of the same dependency to your POM file. But obviously, you only need one set of these dependencies in your POM file. So doing this will then refresh everything so IntelliJ knows that Kotlin exists in that POM file. So it looks like Kotlin is configured in our project now. Let's just run the build quickly and make sure that it hasn't broken anything. Build success, looks like it's working absolutely fine, but we still have Java files. We go over here, we can still see that our file ends in .java and we're looking at Java code. But we have something new now. So if we right click on this file and we can go down here, we've got this option to convert the Java file to a Kotlin file. And we also have this pretty complicated key pattern to do that for us. You might have a different one if you have a different operating system or if you have different key bindings, but this is one that I have at the moment. So we could right click on the file and click this option and convert this one file into a Kotlin file, but there is another option as well. If you go up here to the Java directory, if you right click it, you can see that you don't have the option to convert everything into Kotlin, but if you use the key combination, you can. Now, an option here, do we want it to try and correct some of the issues that might have occurred? Yeah, why not? So we can see now that the Java files are now Kotlin files. Now let's do the same down here to our test directory as well. Okay, and it looks like our test directory now contains Kotlin files instead of Java files. We've got this .kt extension instead of .java. So is it really as easy as that? Let's see. No, unfortunately not. The converter's done a great job, but it can only do so much. We currently have a broken build, but that is good news because this is now an opportunity for us to fix it and learn some Kotlin. So let's start at our application's entry point. So we'll go over here to Books API application, and this is the thing that's annotated with that Spring Boot application annotation. You can see here though that things are a little bit different. We have ourselves an object of Books API application. We have this JVM static annotation, and we have a fun function, as opposed to a main method. But we do still have this Spring Boot application run, passing in our Books API application class, and we've got some args there as well. So let's start with the object here. So an object is like a class. However, you can only have one of that object. It's a singleton, whereas you can instantiate as many instances of a class as you like. Now, the equivalent in Java might be a static class, for example. You can't construct it because it's static. You can think of that as how we would use an object inside of Kotlin. Now, inside of that object, we have this main function. Of course, is the equivalent to a method. Of course, it's much more fun. And this is the equivalent to our main method here. And you can see we've got Spring Boot application run, and then we pass in that class. We also have this JVM static annotation here. Now, this is optional, really. However, it does make it easier to call whatever it's annotating from Java. You can use Kotlin and Java interoperably. Kotlin can call Java, Java can call Kotlin. However, it's usually easier to just use one or the other. They're interoperable. However, Spring Boot wants things done in a particular way for this entry point, so we're going to make some changes. First things first, we don't want an object, we're going to have a class. And we're going to remove these braces here. Let's get rid of that JVM static, And I think we're going to bring that indent in. And there we go. And this might look pretty weird. So we have here a class of Books API application, and we're annotating it with the Spring Boot application. However, we've got no body because there's nothing that will go in that body. So Kotlin allows us to omit it. We don't need any braces. We just have that declaration there. Now we also have the main function, which is existing at the same level as our Books API application class. It's not contained within. It's at that same level, and that's pretty novel. That's pretty different. And there we go. That is how Spring Boot wants things. So let's move on to our presentation layer, taking a look at the author controller first, I think. So if we take a look here, we still have our REST controller annotating our class author controller, where we can see that the constructor is moved from being inside of the class to being at the same line as the class declaration here. So we can see here we've got our dependencies, our author service and our author mapper. That is exactly how Spring would inject them. They're declared right here, but they're also declared with this private val keywords. So essentially this in Kotlin is called a primary constructor, and it's the equivalent of declaring a constructor, but also the instant variables to which the constructor would assign them to, if that makes sense. So essentially what we've got here is a constructor, but we also have two instant variables or properties in Kotlin of the author service and the author mapper. They are private in scope to the class, and they are vals, which is the equivalent of using the final keyword in Java, which means that once they've been assigned, they cannot be reassigned. So if we take a look now at the endpoints, instead of our methods, we have our fun functions. And we have here the create author functions still with the post mapping. And if we take a look through, it looks fairly familiar to Java. I mean, the variables and the types are inverted, but we can kind of figure out what's happening here, except for a couple of things. What on earth is this question mark? And what's with all the drama? What is this double exclamation mark doing here? Which I think is called bang bang, right? So bang bang. What does it do? Well, you see in Java, non-primitive types can be null, right? And you don't really know if they're null or not until you try and call something on them, and then boom, you get yourself a null pointer exception. That's very costly in the grand scheme of things. So Kotlin fixed it. And the way that it fixed it is by having nullable types. So you can see here the author DTO has a little question mark next to it. And that means that author could contain or reference an author DTO object, or it could be null. If that question mark wasn't there, then author would never ever be null. And here's the fun bit. The Kotlin compiler actually forces you to deal with cases where a variable could be null. Of course, there are ways around this, and this is one of them. So if you did want to deal with things exactly how you would do in Java, so for example, bypass the Kotlin compiler trying to help you out, you would use this bang bang. And what this means is you've got yourself a nullable author entity, put bang bang after it, and you have yourself an author entity. One that's not null. One that the Kotlin compiler won't force you to deal with. Of course, that's pretty dangerous because if it does end up being null and you try and call something on it, you're going to get yourself a null pointer exception, and there's going to be very little value in you having these nullable types. So as you can imagine, this bang bang operator is pretty frowned upon when it comes to Kotlin. The converter has used it for us, and we will use it, but we're going to follow the mantra of getting it working first and then making it work well afterwards. But just know, in the production environment that you may be coding in, you don't really want to use this bang bang. There are better alternatives. Luckily, there's a bit of a converter artifact on this one because for the post mapping for the create author, we're always going to expect an author. So if we remove that question mark there, we don't actually need to use these bang bangs at all. There we go. So we are making excellent progress, if I do say so myself, but we are only scratching the surface of Kotlin. If this absolute beast of a programming language is piquing your interest and you want to use it to build real-world projects, then you're going to love this. I'm currently working on a full course with the objective of teaching you how to write Spring Boot projects using the full power of Kotlin. And I am really excited about this one. As usual, I'm going to be releasing a ton of free content here on YouTube, but this time I've listened to your feedback and produced a ton more premium content which builds on the free content, with the objective of building a production-ready, secured, and monitored real-world Spring Boot application written in Kotlin. Perfect if you want to bring Kotlin in at work, if you're trying to get a job that uses Spring Boot and Kotlin, or if you're building your own apps with one of the most popular JVM frameworks and this absolute powerhouse of a programming language. To learn when this course drops and get an exclusive discount, then join the mailing list by checking out the link in the description below. Okay, back to the tutorial. So that's create author compiling there. We've got list authors, which is compiling, no errors here. We can work out what's happening. We've got these authors here. We're calling map on there. Okay, this is very similar to the Java. Get author, again, seems to be working absolutely fine. Okay, it looks like everything is compiling on the author controller. So let's shoot over to the book controller here. Okay, we have ourselves a compilation error. So the reason for this compilation error is pretty interesting. So we can see here that we are returning an if statement to begin with. So that's something that's new with Kotlin. An if statement is actually an expression. You can return an if statement rather than having the return inside of the if statement. Of course, you can also include the return inside of the if statement, but this is something which is very Kotlin. So why is this got a red squiggle under it? And we can see here we've got the response entity with this any type. So the any type is Kotlin's answer to the top level object type in Java. We don't know which type this is. It could be any type. So why is this here in the first place? Well, I don't really know, to be honest. The converters put this in, but we should be able to work out what the type is because, well, we've got this saved updated book DTO. We've got the book DTO type there and the book DTO type there. So Kotlin should be able to infer it. So if we remove the type here, we can see that it compiles absolutely fine. Doing a quick scan of this one, we can see that the converter couldn't really tell which were nullable types and which weren't. Obviously, in Java, any object that's not primitive could be null. So that's what the converter's gone with. We won't spend our time converting those to non-nullable types unless we absolutely have to, but it's worth noting. So that seems to be our presentation layer working absolutely fine. Let's take a look at our service layer now. So we'll start with the author service interface here. We can see it's just normal interface. We can work out what's going on. It's a little bit different from Java, but it seems to be pretty similar. Now, the fun thing about interfaces in Kotlin is they can actually contain implementations as well. This one doesn't, so let's go check out the implementation for it. We have our author service impl here. We have our primary constructor passing in its dependency of the author repository. And yeah, we've got some compilation errors. So this override keyword is underlined, and the override keyword is there. You need that in Kotlin to say that you are overriding something which is in a superclass, or in this case, the interface. So we can see here that rather than the implements keyword, we are basically using this colon to say that our class of author service impl is of class author service. It extends it, it implements it, which kind of makes sense if you think about it. So if we go over here, we can see that save has an author entity, which is a nullable type, but we're getting a compilation error because this one doesn't have a nullable type. Now, I'm going to say that if you're calling the save function, you want to call it with a non-nullable type because you can't save a null, right? So we're going to change the interface here, save it, then go back. And we can see it now compiles absolutely fine because we're overriding something with the correct signature with the correct types. So you can see that Kotlin takes its nullable types very seriously. Now for find all, and this is failing for a very interesting reason. So we can see here we're calling stream support, which if we check out where it's imported from, is imported from Java. So we're calling down to the Java libraries as opposed to the Kotlin ones. Obviously it's Kotlin, but it's doing the same thing as it would do in Java. And we're getting a compilation error because we're requiring our function is returning a list of author entity, but it's finding a mutable list of author entity with a nullable type. So what's that all about? Well, in Kotlin, by default, collections are read-only, whereas in Java, of course, they are mutable. You can change elements in them, you can do what you like. Now, notice I said read-only and not immutable, and there's a whole bunch of nuance around that. You can actually change the read-only collections in Kotlin, but just don't. It gets really, really complicated. However, if they're read-only, then they become a lot easier to reason about. This particular type conflict is because we are getting a mutable list, a Java list, when we want a Kotlin list. So we mentioned earlier, if you mix Kotlin and Java, you can totally do that, but things can get a little bit complicated, and it's usually simpler just to go with one or the other. So we're going to replace this mix of Kotlin and Java with just straightforward Kotlin. So what we'll do is remove everything except for the call to find all here. Now, we know that we want to return a list of author entities. So we've got find all, which is going to return ourselves an iterable. So we're going to call the Kotlin function here of toList, and that's going to return us a list of author entities, but that is currently nullable. So it's a list of author entity. If we were to do this, then it would work, but that's not what we want to return. That's not what we're overriding. So we're going to on toList, call the function filter not null, and that looks a lot simpler, and that's all we need to do in order to implement that using Kotlin. It's basically going to take that nullable type, filter out all of the elements where it is in fact null, and only return the ones that are not null, thereby changing the type that's returned from a nullable type to a non-nullable type. Okay, on we go. Find one seems to be working absolutely fine. It does have a Java optional in there though, where potentially it might be cleaner with a nullable type. We may come back to that in a moment. It is compiling though, so that is our main goal. Partial update is not compiling. Why is that? Well, we can see here that it's calling setID on author entity. So setID, of course, looks like a Java setter here. Kotlin does have the concept of a setter, but by convention, they usually share the same name as the property or the instance variable that they are trying to set for. So in this case, rather than setID, we would just call ID like this. And we do have a red squiggle. Why is that? Oh, okay, because our author entity is a nullable type. So this is the Kotlin compiler making sure that we handle the cases where it could be null. So one way of doing it is by using the save call operator. So this basically says set ID on author entity if it's not null. However, this partial update is always going to receive an author entity. We don't want to be passing in a null to this function. So we're going to go up to the interface here. We're going to remove the question mark from that, making sure that it's a non-nullable type. And in doing so, we can see that, remove it there also, we don't need that save call operator because it's always going to be non-null. So let's get down to this then. So we're calling find by ID, and then we're going map on it. So find by ID, that is returning a Java optional. So we mentioned before we can mix our Kotlin and our Java code, and that's exactly what we have here, but it's usually simpler to go with one or the other. So we're going to replace this implementation with the Kotlin standard, straightforward Kotlin implementation. We're going to start here by, I think, just commenting out this whole block, just so we can reference it. We're going to want to get the existing entity from the database. So we're going to say author repository, and we're going to call, well, we were calling find by ID. So let's just take a look at that. Find by ID wants an ID, which we can of course provide it, and it's going to return for us a Java optional. We don't really want to use the Java optional. We want a nullable type as we're dealing with Kotlin here. So instead of find by ID, we can call find by ID or null, and that's going to return for us a Kotlin nullable type. Now this is really interesting because this is a function that you won't find in the normal Java Spring Data JPA libraries. This is actually a function which is provided because it's a Kotlin extension. So Kotlin has this fantastic feature where you can take a pre-existing library. It might be one that you have written yourself. It might be a third-party one, and you can wrap that library in additional functionality. In this case, Spring Data JPA, we've wrapped that in an additional function which returns a Kotlin nullable type. So we now have this find by ID or null, which is going to return a nullable type of our author entity. We're going to call on that, question mark, because it's nullable, we want a safe call, and we're going to say .let. Now, .let, you can think of this, we're using it similarly to how we would potentially use the map function on a Java optional. It's a scope function, so it allows us to provide a function here which is applied to the thing that we're referring to, which in this case is going to be the author entity that exists. And we can actually give it a name here, so we're going to say existing author. Or by default, the let function, the thing that you're referring to, you can actually refer to it by using it refers to it. But we're going to nest a let function in here. Not something you really want to do all the time, but in this case it makes sense. So we're going to define the name of existing author to refer to the existing author. Now, before we provide an implementation to this, I'm going to deal with the case where the author doesn't exist in the database. Before, you can see here we're throwing a runtime exception, and we might as well just do the same thing. So we're going to use the Elvis operator. and then throw that runtime exception. So the Elvis operator, it's called that because it sort of looks like Elvis's hair if you turn your head and use your imagination. But in terms of this, we're basically saying if the thing on the left of the Elvis operator is null, then do the thing on the right. So if find ID or null returns null, then we're going to throw a runtime exception. And you can see here that we're creating a runtime exception. There's no new keyword in Kotlin, so we just call runtime exception and then in parentheses the stuff that we would pass to its constructor. Exactly the same as we've done up here. Now that we've dealt with when the author doesn't exist in the database, we're going to deal with when it does. Author entity, the thing that's being passed in, if it has a name, which is a nullable type, string with a question mark after it. So we want a safe call on it. So if it's being provided, let's put that question mark in the right place, shall we? If it's being provided, if it's not null, then we want to do something with it, which in this case, we're going to, on the existing author, reassign the name, which is a var, so we can do that, with whatever is being provided, which of course is the name in the author entity, which we can refer to by using it. We're using let up here and we've given it a name. We're using let down here as well, which by default, the thing that it refers to is it. So we're going to use it. If we didn't provide a name up here, it would be ambiguous and we would be forced to provide a name for one of them. So we've jumped ahead and we've done that. So we've got name. We're going to do the same for age as well, because that's what we're doing up here in this implementation. There we go. And then it's calling author repository.save. So we'll do the same thing here, author repository.save, and it's doing it on the existing author. Go, and let's remove that commented block. So something to point out about this one is because we have these braces here, the function that we're passing to let, we don't actually need to use a return keyword. It's by convention the last thing that is in this function, the last line, that's going to be returned. And we've got here the result of our save function, which is going to be our saved author entity. So everything compiles absolutely fine here. So we now have a working author service import. Let's take a look at the book service interface. Yep, exactly what we'd expect. Pretty much identical to how it was in Java. So let's take a look at the implementation of the book service. Okay, so if we do a look through here, it looks like all of the issues we were facing in the author service import. So I'm going to speed through these because you've already seen the solution once. So let's get these done. Okay, so that's all done. If we take a look at our persistence layer, this is still pretty much the same. We happen to use Spring Data JPA, which provides the implementations for us. So the interface and everything is working fine for the author, and for the book, the implementations will be provided as it usually would. So let's do a couple of tidy ups, and then we will go on to running all of our tests and seeing if our application actually works. We're going to start with removing those Java optionals because you're here for the Kotlin, right? We don't want Java optionals in here. So let's go back to our services, start with the author service. And instead of an optional, we are just going to return for ourselves an author entity of a nullable type. Just make sure we've got no other optionals in there. None at all. We're going to do the same for the book service as well. We don't want an optional. We want a nullable type. Let's go back to the author service impl. It's now going to flag up that, hey, we're not returning a nullable type. We're not overriding the right type. Find by ID, or null. That was easy. Let's go to the book service impl. We're not returning an optional anymore. Find by ID or null. Looking good, but of course we're calling these, and we were dealing with an optional before, so let's find the usages. Okay, so we can see here that it's trying to call .map. Of course, that doesn't exist anymore, so we're going to replace that with a call to let. There we go. And let's do the same over on the book controller. There we go. So instead of map, we don't need that anymore. So we're going to replace that. There we go. And we don't need or else. We're going to use the Elvis operator. So we no longer have Java optionals. Let's get rid of everything that was Java. So if we look here, we still got this Java directory in a Kotlin project. As you can imagine, this wouldn't be Java, this would be Kotlin. So we're going to change that. Okay, that's now Kotlin. Let's do the same for our test down here. So the last thing that we need to do before we can run our test and run our project is just get everything configured in our POM file as it should do. Remember earlier when I said there's going to be some additional stuff that we need to do? Well, there is. So let's head over to the POM file now. Okay, So we have our Kotlin plugin, which is down here, but there's some additional plugins that we need to apply to our plugin in order to get it working absolutely fine with Spring Boot. In particular, the Spring Data JPA side of things as well. So what we'll do then is I'm going to replace the plugin configuration with one that I have borrowed from the Spring Initializer. So you've got a few things in here which I'm going to point out to you, but we're only going to go at a high level. So you can see this has compiler plugins for Spring, no surprise there, as we're using Spring, and then JPA because we're using Spring Data JPA. In addition, we've got here the Maven All Open plugin and the Maven No Arg plugin. So this is a way of bridging the gap between the Java that the Spring libraries expect with what Kotlin would generate. All open. By default, classes in Kotlin are essentially final, closed. You can't subclass them unless you declare them as open. So this is basically just making sure they are open because inside of the implementations for Spring, it expects that. And the same for no arg. So by default, you wouldn't have a no arg constructor inside of Kotlin just for free, but this one will put them there for you, and this would allow it to work absolutely fine with Spring Boot. One more thing though, we are going to need to put in an additional dependency up here. So you can see already we've got the Spring Standard Library, we've got Kotlin Test. We are going to need to include the Kotlin Reflection dependency. Okay, and if we refresh this, so the Kotlin Reflection dependency, we're not using reflection explicitly, but it does use it under the covers. So we want to make sure that it knows how to do that with Kotlin. So we're going to include that library as well. I do believe our project will build now. So we're going to open up a terminal here. And whereas before we had this failure, we're now going to run exactly the same Maven clean install and see what we get. Okay, it looks like all of our main code is compiling, and that's fantastic. But it now looks like our tests are no longer compiling. So let's take a little look at these. Okay, so it looks like it's mostly type stuff in our tests. If we take a look at this one as an example, it required a long, but it's got itself here an optional long. And by the look of things, it's mostly the same for the other tests as well. So what I'll do then is I'll shoot through and make sure all of the types align, and then we'll run this again, hopefully with the test passing. Looking good. Let's run this once more. So the tests are running. So it looks like the compilation's gone absolutely fine. But if we take a look here, we have ourselves some failures expected in ISBN, but it's getting itself a null. What could possibly be going wrong? Well, I think the easiest way to deal with this is actually if we just run it in the IDE, and then we can get everything linking up. So we can see that the controller tests are failing here. Here's our body. Its ID is null, the name is null, and the age is null. They're all null. That is not at all what we're expecting, but it is expected in a way. So if we take a look at how we are dealing with our objects inside of the controller, inside of our presentation layer, you can see that we're using this mapper. So we're using this mapper to decouple our presentation layer from our service layer and our persistence layer. So in our service layer and our persistence layer, we're using entities, those JPA entities, which basically represent the objects, how they're stored in the database. It isn't necessarily how we want to present them to the user. We might want to do something slightly different in a REST API, and if we were to introduce a different presentation layer, maybe a GraphQL API, for example, we might want to do something completely different there. So it does make sense in a lot of cases for these presentation layers to have their own DTOs or data transfer objects. And to convert from one to the other, from our entities to our DTOs and back again, we're using these mappers. Now, if we take a look at the mapper here, it's very straightforward, map to, map from. But if we look at the implementation, we're using this model mapper, which is from a model mapper library. So the model mapper library uses some pretty clever reflection in order to convert automatically from one class to the other. Java reflection, and we're in Kotlin. So this is a good lesson, which is if you are using a library which does some pretty clever Java reflection, you might not expect it to work in exactly the same way in Kotlin. Model Mapper is a prime example, and Delombok is another great example. Luckily, we can provide a different implementation for our author mapper and our book mapper, and everything should continue to work. We don't want any nullable types in here. If you're passing in an author entity, you're going to get an author DTO and back again. So let's make sure everything lines up. Let's provide an implementation here. So we're basically going to construct an author DTO, passing in the information from our author entity, which goes ID, name, and age. As it turns out, we're doing the inverse down here in map from, but of course we're going from an author DTO to an author entity. And you can see how some of these libraries can automatically generate this. This is fairly boilerplate. So that is our author one done. Let's do the same for our book. Okay, so let's remove that nullable type. Okay, so the book DTO actually references the author that wrote it. We're going to have to take a look at the domain objects. So I wanted to hold off on looking at these domain objects because even though they're technically right, they're a little bit involved. And it's a direct result of us delomboking them and then using a converter to go from Java to Kotlin. So even though they're technically right, there's a lot to it. So if we see here that the book DTO can have an optional author DTO in the author variable here. So we need to pass in a dependency to our mapper here, which we can do via the primary constructor. Now we can go book entity. Now author could be a nullable type. So we're going to say .let, and then we're going to use our author mapper I think it was map to, passing in it. Good, and we will do the same down here, but of course we're going to be constructing a book entity. And instead of mapping to, we're going to map from. So there's our mappers. As this will be quite a nice visual, let's now run all of these tests again and see if they pass. All of our tests pass. So let's just wrap this up before we test to make sure that our application can actually run by opening up a terminal here. And we're going to run Maven clean install, and we're expecting this to go without a hitch, be a complete success. So we have a build success. It looks like our project has been successfully converted from a Java Spring Boot project to a Kotlin Spring Boot project. So let's see if this actually runs. So as mentioned earlier, this project depends on a PostgreSQL database, so we need to run that. Luckily, we have this Docker Compose file here. So we're going to say Docker Compose and up. And this will start up our PostgreSQL database for us, ready to accept connections. And we're going to go to our main function that we had from earlier, this one here. And we're going to click this little green tick, and we're going to run our Kotlin application. And it started successfully. So let's see if we can actually interact with this application. Let's bring up Postman. So here we are in Postman. If you haven't come across Postman before, it basically allows us to interact with REST APIs. It gives us a user interface to do that. So what do we have? We know that we're running on localhost on port 8080, and we have this author's endpoint, post endpoint. So what this is going to allow us to do is create an author in the database. We also have various other endpoints. So what we'll do actually is we'll take this, we're going to paste this in, and instead of using post, we're going to use get. And this is going to list all of the authors that we currently have in the database. Looking good. We got a 200 OK, and we got an empty list. So let's flip back to the create endpoint, and we're going to create ourselves an author called Colin, and he's going to be 24 years of age. So if we send this away, we can see here we've got a 201 created. We have the ID of 1. We have Colin, and his age 24. If we now click on the list endpoint once more, we've got our author Colin returned in the list. So it looks like our Kotlin Spring Boot application is working absolutely fine. And there we have it, a Kotlin REST API all your own. If this is your first experience of Kotlin, what do you think? Better than Java? Overhyped? Let me know in the comments below because I'd be interested to hear. Now, if you want to learn more about Spring Boot, you want to learn more about Spring Boot in Java, in which case, check out this full course right here. Because over 6 hours, I'm going to take you from a complete beginner to being proficient with Spring Boot in Java. I'll see you over there.